Today, we're going to be proving the theorem. If a point is on the bisector of an angle, in other words, I'm talking about D right here, then it is equidistant from the side of the angle. In other words, that if this right here is the bisector, then this point B and D will be equidistant from that. Okay? So we have an angle BAC, and we have the bisector AD. And we want to prove that BD is congruent to CD. And what I'm going to do is construct this line right here of BD is going to be perpendicular to here, and it's likewise from here to here. And the reason I do that is because I have down here that the directest line to that is there's a straight line which is going to be perpendicular, so that's going to be the shortest distance. So we have given the angle and the bisector AD. We also know that angle 1 is congruent to angle 2 because they've been bisected, so they've been split in two. We know that angle 3 and angle 4 are congruent to each other because we constructed them to be perpendicular, and we know that all perpendicular angles are congruent. Angle 5 and 6, we know that the sum of a triangle is 180 degrees, and if 1 and 2 are equal and 3 and 4 are equal, then therefore 5 and 6 have to be equal because they both equal to 180 degrees. And we have this line right here, AD, which is going to be common to itself, which is the reflective property. And we also know then that the triangle ABD is going to be congruent to ACD because of angles, side, angles. So we have the angles, the side, and the angle. Okay. And from that we know that BD is congruent to CD because they are corresponding parts of congruent triangles. Therefore, we have proven this. Now, let's look over here at the converse of that. The converse is that if a point is equidistant from the side of the angle, in other words, this distance from here is equidistant with that, then it is on the bisector of the angle. Again, we have given the angle, we have given point D, and we've been given that CD and BD are congruent to each other. Now we're going to try to prove that angle 1 and 2 are congruent, because, in other words, that they've been bisected by the angle. We know from here that from the given, restatement of the given, we know that angle 3 and angle 4 are perpendicular because they're perpendicular angles, because all perpendicular angles are congruent. We know that AD is common to itself, so therefore it's the reflective property. And then we also know that triangle ACD is congruent to ABD because of the hypotenuse leg of a right triangle. So we get the hypotenuse and we got the legs. Okay? And well, that concludes then that angle 1 is congruent to angle 2 because of their corresponding parts of congruent triangles. So now we have concluded this, both the main one and the converse. We have proven both of those. Thank you.